normal kinematics, but you have to deal with it in both x and y. So you'll have your orange equations. V final x equals v naught, v initial x plus at. Y, you have v final y equals v initial y minus gt. So you'll have delta x equals v initial xt plus 1/2 at squared.
So did you crash your?
And therefore, delta y equals v initial yt plus 1/2 minus 1/2 gt squared. Makes the third v final x squared equals v initial x squared plus 2a delta x. So v final y squared equals v initial y squared plus minus 2g delta y. And so, usually with the x-axis there's no acceleration, so you don't have to worry about that. And in some situations, you can exclude other variables from y as well. For example, if you're solving for the maximum distance, there's no y. Or if you're solving for maximum height, right here, delta y max, there's no v initial y. So we can go ahead and solve for that. So this would mean that all of these, this would be final y. So that means that all of these, that goes away. So we'll go ahead and solve for this. We can say that delta x is 50 meters. We'll say that the initial is 10 meters per second at an angle of 45 degrees. And so we want to find, if we want to get to this, we're going to find the bridge between them is time. It's the same variable on both sides. So we can take 100 meters. We'll do 100. So we'll solve for the time right here. So delta x over 2 equals v initial cosine theta t. And so we'll do 50 divided by 8.5 equals 5.88 seconds. That's how long it takes to get from x equals 0 to x equals 50. So you apply that to the third orange, and this is the two we're using this time, to find delta max. So it's called v final y equals 0. You can take v initial y is squared equals 2g delta y. V initial sine theta squared equals 2g delta y. So this and this, for this case, equal the same thing. So, or square, that should be 72.25 divided by 19.62. Should equal 3.68. Seems a little small, but that's what it is for this example. And so you can
go.
So for different examples, you remove other variables and focus on different equations. Same equations in different orders. And so, like I said, perhaps you have one, you're solving for delta x. It'd be pretty much the same, but instead of excluding v final y, it would actually be the same as v initial y. V initial y would be final. And since you're going from the ground to the ground, delta y would equal 0, which simplifies the equation, as you can tell. And there are some that you don't get any breaks for, like something falling you're not going to get anything. You have to find V initial and V final and delta X and delta Y all separately. So that's a pain in the butt, but it's still all you have to apply everything together and it all works.